In this installment, we'll talk a little bit about why water and other liquids reduce friction. To do that, we'll zoom in here. On the top, we have a material, let's say your shoe, and the bottom material is the ground, and there is water there like so. Now, one thing that makes a liquid different is that the molecules themselves are free to revolve They're free to revolve or rotate and spin in any direction they want. There is no bonding between the molecules of any significance when compared to the shearing forces of the material above and the material below. And of course, not only can they revolve in the directions I've indicated, they can revolve into and out of the board, or into or out of the page. So they are free to move, slide past each other. In fact, liquids, that's what they do. They roll and roil around each other constantly. And if you increase the temperature of a liquid, the more of that roiling and spinning around those molecules do. And in the next diagram, if we just to show it, make a different point, even if a molecule is connected to the material above, the surface above, say your shoe, there are multiple layers of them and they're able to slide past each other. So even if this row and this row remain fixed, or even if the top row remain fixed, the two layers below it are free to move as they see fit. So even if there is some adhesion of the water molecules to the surface, all the water molecules below are not similarly attached, and so they're free to rotate and revolve themselves. And we can see that even more detail in this next diagram, where you could see that the water molecules are connected, adhered to the material in those grooves. But again, the molecules down here are free to roll and roil in any direction that they so choose, so there isn't any rigidity holding these in place. So then if we have a body at rest, and we say that we want it to accelerate in this direction, and this is the ground and it's fixed, well, when we accelerate in that direction, no matter what happens with these water molecules in the first row, whether the adhesion holds or not, the water molecules below are free to revolve and rotate all the way down through, because the bonds are not rigid. So that is why water and other liquids reduce friction significantly. Now, on a similar and related vein to that is a case like this where we have a heavy object, and it is claimed that in Stonehenge they had these 100-ton blocks of stone, and they would move them across the land by rolling them on logs. So that's the sort of situation we have here. Well, what is going on with this at a molecular level? Well, what we have is a force where this is being pushed to the right. And if we look at the molecules close in like this, as the block rolls, is pushed to the right, the molecules here remain stationary. In other words, there is no sliding of those atoms past each other. There is friction, static friction, and that allows and causes this to roll in this direction as the particle moves to the right, or the block moves to the right. And similarly, down here, where we have these wheels, there with those molecules, there is no sliding. And so that causes the wheel to be propelled and move in the same direction as the block. So overall, when we are pushing this block, all of these rollers will roll in this direction. There'll be no sliding anywhere around the ground, and no sliding near the top, causing them to roll. But what is an interesting outcome of all of this, when we look at it close up, is that for wheels, tires, to roll, there could be no sliding. So even though the whole thing is in motion, the molecules, the atoms themselves, are not sliding past each other. They are stationary. So to get traction requires static friction. This is why I despise and recommend not using the word kinetic friction, because there's all kinds of movement here of the bodies, the bodies in question, but there is no motion of the atoms relative to each other in those surfaces. It's sliding. So we should not use kinetic as a word as it relates to friction. Completely misleading. And so that is why water and other liquids reduce friction, and also how wheels and rotating bodies work and rely on static friction.